Hello and welcome to our second circle pre-lab. In our first circle lab, we figured out that there was a relationship between the circumference and the diameter of any circle. We found that they were, of course, directly proportional to one another. And then we found that we could relate them in a math model through that very special number pi, the ratio of the circumference to the diameter of any circle. So we discovered pi and the equation circumference equals pi times the diameter, or 2 pi times the radius. Well, in this lab, we're going to look at two other properties of a circle and see if there's a relationship. And those two properties are the area of a circle, which we will denote with a capital A, and the radius of the circle, which we will denote with a lowercase r. And so the purpose of this experiment is to create graphical and mathematical representations of the relationship between the area and the radius of a circle. So this time, area and radius. Now, again, this might be a lab where you actually know the relationship, the equation already, but if you do, please forget it. Don't use it as part of the lab. We're going to discover it, or construct it, if you will, through the process of the lab. So how are we going to measure the area and the radius? Well, we're only going to use one measuring device, and that measuring device is a piece of graph paper. Now, this piece of graph paper is special in that it is 1 centimeter on a side, so each line is 1 centimeter. So what you're going to do is you're going to get your circular objects, the same ones we used in the previous lab, and you are going to trace the circle out onto your graph paper. If each line is 1 centimeter on a side, then that means that one of these little squares is 1 centimeter squared of area. So you'll have to count all of the little squares in here. And then you'll notice the ones on the outside are only partial squares. So you're going to have to estimate, estimate, estimate. To get good data in this lab, those that get the best looking graphs will be those that actually try to estimate. Don't just say, oh, that's basically 1. No, it's less than 1. It's 0.9 of 1, and this might be 0.3 of 1. And just kind of try to keep track of how much all the way around. Okay, so that's how you're going to measure the area, by counting all of these squares. The radius is fairly straightforward. You can measure the diameter, realizing again that each one of these is a centimeter. Again, estimate if you need to, like you would up here. And then since the radius is half the diameter, take that diameter, cut it in half, and you can record it. Notice we are not using any equations here. We are measuring the area and measuring the radius. So you will then, of course, want to put it in a nice data table. Notice that the first data point here is 0, 0, which makes logical sense if you think about it. It means that when the radius is 0 centimeters, the area of the circle is 0 centimeters squared, which of course would be true. If there's no radius, then there's no circle, which has no area. And so put 0, 0 in. It will help the graph look better. And then there are, in my class at least, 9 circular objects that you will use. And of course, once you collect all of your area and radius data, you will then graph it. And your graph, as always, should have a nice title. You should change the column headings and the units. There is a way, by the way, to put this little squared thing here. When you're typing in Logger Pro, right next to it, there's a little pull-down caret. And if you click on that caret, one of the things you can do is put a superscript on it. And then you can make it look pretty like this. And so you're going to graph area on the vertical axis, please, and radius on the horizontal axis. And graph your points. And unlike the first circle lab, it's not going to end up being a straight line. It's going to be a curve of some type. So today what we want you to try to get through is to do all of your data and make your graph on Logger Pro. And then call me over to take a look at it, right, so that I can okay your graph. You'll save it. And tomorrow we'll talk about how to do something called linearization, where we take the curved graph and turn it into a straight line so that we can make a math model from it. Okay, so again, don't use any equations. Measure precisely, estimate on the graph paper. Okay, record your data and make a nice graph and call us over to take a look at it. Hopefully that's the part of it that we'll get done today.